Good morning, guys. Today we're going to be looking at maximum flow networks. These are pretty complex to start, and they require, of any of the topics, a really systematic approach. So hopefully over this video I'll start off with question 4 from the book, and then I'll also do question 9. Question 4 is a little bit easier, question 9 is a little bit more difficult, but hopefully you can see that with a systematic approach the questions actually become quite easy, and the math behind them is not too difficult. Okay, so what we're looking for is the maximum amount of flow I guess we can get throughout this entire network. To start, I'm going to pick a route from A to X. So let's say we've got A, B, X. And so we think to ourselves, if we were to, put water through here, we could get 50 litres through AB, but then it's going to be restricted when we go to BX. So through ABX, the most we could get in there is 40 units. All right, and if we did send 40 units in there, this 50, we'd have 10 units left over here, and this 40 would become 0. Okay, so for each of the routes that you pick, you need to subtract I guess the smallest number off of all of them, because if we were to send water in here, this would be at max capacity, and this one would have 10 units that could also still flow in there. And to make that point clear, while we just did that, we're going to choose another route now, which will be A, B, C, X. All right, so we're going to send some water through A, B, C, and then through to X, and you can see that we can get 10 units of water there, 10 units of water there, and then we can fit 30 in here. All right, but because we're sort of restricted at the start here, we can only send 10 units in. So we can only send 10 units there. This would become 0, all right, because the 10 units that we had left over from A, B, X is now being used. This goes down to 0 because we've used that, and we can also subtract 10 off there. All right, next, you can see that we can send some water through ACX. Clearly, we're only going to get 30 through there. That's going to come 0. That's going to become 0, and we can fit 30. This network is looking quite neat because we're all at 0. Chances are in the test there will be some leftover, and that's okay. There will be leftover in the harder questions. Now we've got ADX. We can send 20 units of water through there because this path from D to X is letting us down. That's going to become 0, and we can fit 20 in there. And then you can see that I can't send any more water in through this entire network because the only flow I have left is this path here with 10, but then it's going to get to this point, and then there's going to be no water. There's going to be no water capacity left in that path. So it was our maximum flow. So if we just add these up, we get 100 units. And that is our maximum flow through this network. All right, this one, question 9, is a little bit more difficult, but the same process will apply. And I don't know if you noticed when I answered question 4, but I started with the top route and I just sort of made my way down through the network. So here we've got A, B, Z to start, and the flow I have through there is 100, so that's going to become 0. That's going to become 150, and I had 100 units. Next, I might go A to B to E to Z. So we can fit 150 there, 100 there, but only about 300 there. So clearly the lowest value there was 100, so we can only fit 100 units in there. That's going to become 50, and that's going to become 200, and we fit 100 in there as well. Now, let's just pause here for a second before we go to the next route. If we go A to B, we've got 50 units available, but from here we can't use any more flow through those two paths. All right, so we're really restricted in this top section, and that's okay. There's going to be leftover. So next, we're going to go from A, C, E, Z. So we've got 250, then 100, then 200. So C to E is letting us down a little bit. The maximum flow we can fit through that path is 100, so that's going to become 150, That's going to become 0 because we've used all of that. And this is going to come down to 100. And we used 100 as well. Next, we can use A, C, F, Z. The lowest we can use is 100. Or the most we can use, I should say. So that's going to become 50, 0, 150, and 100. It looks like we've got our last path again. Looking at AC, we can use 50 there, but we're restricted. We're restricted here because that's down to 0. Even though we've still got some flow left in AC and EZ, CE is letting us down. Okay, then we've got A, D, F, Z for our final one. And we can get away with 150 there. So that's going to come down to 0. Just put that there. 150, that comes to 50. And that goes to 100. All right, so let me just make sure I did that right. Yep. This is our maximum flow. Again, realizing that none of that, we realized before that we have no flow here, and we also have no flow here because we're down to 0. And then we can even think to ourselves, well, can I do this? No, still doesn't work. The total of this is 550 units. The only other thing I might want to say, notably, you can tell in this question that we have unused flow. And, there's 50 there. And so that's that. We've got another 50. This is just so, just to help your understanding here. And 100. So that's 350 unused. Yeah, so that's maximum flow networks, from one easier sort of question to one harder sort of question. Again, I'll reiterate, it just requires a systematic approach.